All right. So last week we did solving quadratics by factoring, right? And then we did solving quadratics by taking the square root. And the square root was actually pretty hard because we had to simplify the radicals, the square roots, right? And that was actually kind of hard. In fact, I didn't have enough coffee to do it last hour. It was really difficult. Anyway, let's. Section 1 is solving quadratics by factoring. So the only difference between this and regular factoring is that we set each factor equal to 0 and we find out what the variable equals, right? All right, following your flow charts, which you can use on the quiz Wednesday. It says the first thing to do is to take out any common terms, right? So I do have some common terms here. I have a 5 that can take out of the numbers, right? Oh, I'm going to use a pen. I thought I was using a pen. I can take out a 5. And how many? Can I take out any p's? Yeah, I can take out 1 p, right? Okay, so 5p squared divided by 5p. The only thing I have is p to the first, 1p left, right? 25p divided by 5p, bless you, is 5. Okay, set each factor equal to 0. This is a factor, 5p. Even if I just had p, bless you, that would be a factor. So I'm going to set 5p equal to 0, or p plus 5 equals 0. Keep going. Just if 0 is a number, right? So if I want to get p by itself, I would divide both sides by the coefficient 5. So here, p equals 0. And if you want to put the word or, that's fine. You don't have to. And here, I would subtract 5 from both sides. And I get p equal negative 5. You can shorten this up. Let's see, you could put p equal negative 5 comma 0. That's another way to write it. Okay. I don't know if I like the seating chart. I can't see everyone's eyes. I have to move to see your facial expression, your eyes. Well, I'll have to think about it. All right, number 3. Trinomial. I cannot take out any common terms, so I'm going to go ahead and factor it. Only one way to get x squared. That's x times x, right? Let's see. They're going to multiply to a negative. Oh, let me do the factors of 10 first. So you have 1 times 10, 2 times 5. That's it, right? The sign is they have to multiply to a negative, so it's going to be a positive times a negative or a negative times positive. So since they have different signs, we're going to be subtracting our factors, right? And when we subtract them, they're going to have to subtract to a positive 3. So I'm just going to start with the 2 and the 5. I'm going to hold off on the sign because I don't know which one goes where. So I'm going to do my middle arch, I get a 2x. My outer arch, I get a 5x. And when I subtract 2 from 5, I'll get my 3. Okay. I want my 5 to be the positive and the 2 to be negative because I want a positive 3, which means my 5 is going to be positive and my 2 is going to be negative. So there's my 2 factors. x minus 2 and x plus 5. And then set each one of those equal to 0. This one's actually pretty easy, right? It's just going to be opposite the signs that are there, because you're going to add 2 and subtract 5. So I'm just going to go ahead and tell you what x equals. It equals positive 2 comma negative 5. So there's my answer. All right, number 5. Again, I can't take out any common terms. There are none. So this time, it's a little harder because I have a coefficient in front of my squared term, my squared variable, right? But it's still a prime number. The only way to get 2a squared is to take 2a times a. Factors of 15, 1 times 15, 3 times 5, right? Again, it's a negative. They multiply to a negative, so I got that positive times negative, negative times positive thing going on. Which means different signs. I have to subtract these. And one of these is going to be multiplied by 2. So we got a little work here. Okay. Here's my inner arch and my outer arch. Let's see. I'm just going to put 3 and 5 in there and see what happens. Okay, 3 times a, 3a. 2a times 5 is 10a. And if I subtract these, because different signs, remember, I'll get a 7a. And that's what I want. So I actually guessed right. All right, so I want the bigger number. That'll give me my 7a. I want the bigger number to be negative because I want to end up with a negative. So this is negative, this is positive. Which means my 3 has to be positive and my 5 has to be negative. So there's my 2 factors. Took us a little bit of work. Now this factor is easy, right? Here a is going to equal positive 5. I got some figuring to do on that one. So I'm going to take 2a plus 3, set that equal to 0. Going to subtract 3, subtract 3. So 2a is going to equal negative 3. And divide by 2. Divide by 2. So this a is going to equal negative 3 halves. Okay? Questions? All right, let's do number 7. Can't take any common terms out. There are none. But this is a binomial. And the 4 and the 25 are perfect squares, right? So I'm going to rewrite this. 4 can be rewritten as 2 squared. N squared stays the same. 25 can be written as 5 squared. So then I can use my shortcut formula. The base 2n plus the base 5, the base 2n minus the base 5. Now, I'm only going to set one of these equal to 0 and figure it out because the other one's just going to be the opposite of it. Okay, so I'm going to take 2n plus 5, set that equal to 0. See, I'm going to subtract 5. I get 2n equal negative 5. and then divide by 2. So this n is going to equal negative 5/2, which means this n is going to be positive 5/2. You can even shorten this up a little more, right? With that little symbol we learned last week. Plus or minus, right? Plus or minus 5/2. Good, Luna. All right, square roots. The hardest thing about square roots, I thought, was simplifying. Now, always check I even get rusty on the perfect squares, okay? Especially numbers after 10 because we don't normally do problems with it. So always check to make sure that this number is not a perfect square, which I did that mistake last hour. So I'm going to take the square root by hitting the second key. Okay, so hit the second key and the x squared button. That brings up the square root. I'm going to put 256 in there. And I'm going to hit enter. And I get the whole number 16. So the square root of 256 equals 16. Got lucky on that one. Do the same thing with 252. Square root of 252. Well, I get a decimal, so that's not a perfect square. So, there we go. We're going to have to simplify the square root of 252. Now, 252 is a really big number, right? To try to get all the factors of 252. Well, we can always do 1 and 252, but that doesn't help us. So instead of doing all of the factors of 252, I'm going to do the whole number, the perfect squares, see if they're factors of 252. Remember what the, here, I'll write them up here. Perfect squares are? Let's see, 1 squared is 1. 4. Good. Good.
26, 49, 64, 81, 100, 121, 124, 169, 196, 225, 256, 289, 324.
Wow, you're way ahead of me. 225. 256, right? 256, 16, 17 squared is... Thank you. I couldn't remember that one.
361.
And then 400. Yeah. Okay. All right. So instead of trying to figure out all of the factors of 252, because there's a lot of them, I'm just going to start by using the perfect squares. First of all, I'm going to take 252 and divide it by 2. Okay? I'm going to take 252 and divide it by 2. Right. 126. So I'm going to start... I need the largest perfect square that's a factor of 252, right? So I'm going to start at 126, which means I'm going to start here at 11 squared, right? 121. And see if 11 is a factor of 252. 252 divided by 11. Nope. Okay. So I know 121. I'm going to take 252. And instead of 11, I'm just going to do the perfect square. 100. I know that 252 isn't going to be divisible by 100. So I'm going to try 81. 252 divided by 81. Nope, it's a decimal. So 81's not going to work. Okay, 64. 252 divided by 64. Decimal, that doesn't work. 252 divided by 49. Decimal. Maybe I should have went the other way, huh? 252 divided by 36. Oh, I get a whole number 7. So 36 is my perfect square times 7. Does everybody see how I did that and why I started at 121 or 126? Yeah, if I start going over 126, then I'm just starting to repeat myself. Okay? That's why I divided by 2, and I find out where to start with my perfect squares. I started with 121, 100, 81. I just see which, I keep going down the line here. 36 is the largest perfect square that's a factor of 252. Because otherwise, my last class, I did the whole list of factors of 252. There's a lot. Okay, so I'm going to do the square root of 36, the perfect square first, times the square root of 7. The square root of 36 is 6, and what's left over is the square root of 7. So when you get a really big number like 252, just start dividing it out by the divide it by 2, and then start dividing it out by the perfect squares. Okay. And then the reason why we did this whole simplification of radicals is because then we started to solve quadratic equations using the square root. Okay, so this one has n by itself. So we're going to go ahead and take the square root of both sides because it cancels out the power 2. And I end up with n equals, now, because we're dealing with variables here, we have to put that plus or minus sign in there. So the plus or minus the square root of 61. Now, you have to see if 61 is, if it can be simplified. The square root of 61. Again, I'm going to divide by 2. When I divide by 2, this is going to be what, 30? Somewhere around 30.5. I have 2 and 30.5. Good. Okay, so I'm going to start with 30.5. So I'm going to start with 25. Okay? Because that's the largest perfect square that's below 30. So I'm going to start with 25. 61 divided by 25. It's a decimal, so that doesn't work. 61 divided by 16. The decimal, that doesn't work.
I thought you were dividing 30.5.
Now that gives me my starting point where to start with perfect squares. Okay, so that gave me the starting point in 25.
Got it.
Okay. So we did 16. Then we're going to do 9. 61 divided by 9. Decimal, doesn't work. And 4. 61 divided by 4. The decimal. So this cannot be simplified. I'm highly confident this should be n. That this is my answer. Questions? Let me do 2 more, and then I'll let you off on your own.
We aren't going to do 19.
No, we're not going to do these. I don't think I'm going to put absolute values on your quiz Wednesday. I might put something else on there. I'll let you know tomorrow. Okay. All right, so we're solving these by square root, which means we have to get the square term by itself, right? So I'm going to subtract 3 from both sides. That gives me 2n squared equals 140. And then I'm going to divide by 2. So I get n squared equals 70. And I was already thinking ahead, trying to figure out if there's any perfect squares that's a factor of 70. Square root both sides. So n is going to equal plus or minus, don't forget the plus or minus, square root of 70. And square root of 70 is simplified. So I'm done. And 17, let's see, we have to get the quantity by itself first, so I'm going to divide by 4 first. Good. So I get r, the quantity, r plus 4. I have to put them in parentheses still because I still have that power 2. 8 divided by 4. Take the square root. Now that I don't have any mathematical operations to that quantity, I can drop my parentheses. R plus 4. Don't forget the plus or minus. Square root of 2. And then subtract 4, right? By the way, 4 and square root of 2 are not like terms. So you have to keep them separate. So r is going to equal negative 4 plus or minus the square root of 2. And then, for now, don't worry about 19 through 26. Just do 2 through 18 evens. Just do the evens, 2 through 18.
Can we list it to even?
Yes, but no video games, all right? Or videos or movies or anything else in that category that disturbs you from doing your work. Okay? Because I know you guys, you'll come up with all kinds of excuses. Well, you didn't say billiard tables